All right, what's up, Advanced Geometry? Mr. Donaldson, and we are going to finish up these 9.3 notes. So after you just did the warm-up, the hope was that you saw a pattern. And so the pattern that I hoped you saw, we'll start, of course, with the 45, 45, 90 right triangle. And before we talk about the pattern, I suppose, let's identify the sides that we have. So in a 45, 45, 90, of course, you have a hypotenuse. That's the side across from the right angle. You have two legs. Now in a 45, 45, 90 triangle, not sure what happened there, the legs are congruent to one another. So, if the leg was x, then of course the other leg was x. They're equal to one another. So I like to draw a little arrow showing my little equal sign. And then what we know is that in order for us to go from the leg to the hypotenuse, we simply needed to multiply it by the square root of 2. So I'm going to ask you on your notes to draw this little arrow, and we're going to just use this map when we solve these problems. So in a 45, 45, 90 triangle, to go from the leg to the hypotenuse, you multiply the leg by root 2. So this is our map for a 45, 45, 90 triangle. In the 30, 60, 90 triangle, we have the hypotenuse, of course, the side across from the right angle. But in this case, we have a long leg. Now, the long leg is across from the 60-degree angle. And we have the short leg. And the short leg is across from the 30-degree angle. And everything we learned about the 30, 60, 90 triangle is relative to the short leg. So, if the short leg was x, what we learned in the warm-up is that to get the hypotenuse, you double it. So we would times it by 2. That would make the hypotenuse 2x. If the short leg was x, to get to the long leg, what we saw in the warm-up is that you multiply by the square root of 3. So that will make the long leg x root 3. So we will use this map, and we'll refer to short leg and long leg and hypotenuse when we do the following examples. So what I'll ask is that we do the first couple together, and then I'll challenge you to maybe try the next ones on your own by pausing and then checking by restarting the video and seeing what I got. So let's do these together first. So the first step is identifying the type of triangle you have. So this one is a 45, 45, 90. And I know in a 45, 45, 90 triangle that the legs are equal to one another. So that means if this leg is 8, then x is 8. And that's easy enough. And then the other thing we know about a 45, 45, 90 triangle is the shortcut to get to the hypotenuse is you simply take the leg and you multiply by the square root of 2. So when we take 8 and we multiply by the square root of 2, that's what we get. We get 8 root 2. So this is a pretty simple example of how to do it. And of course, they'll get a little bit trickier. All right, the next one's kind of simple as well. All right, so we have our 30, 60, 90 triangle this time. And so I'm going to go ahead and identify that this is the long leg. We'll call it LL. This is my short leg, SL. And this is my hypotenuse. And remember, we're given the short leg. And the way the 30, 60, 90 triangle works is to go from the short leg to the hypotenuse. We multiply by 2. So that's just 5 times 2, which makes y equal to 10. And then to go from the short leg to the long leg, we multiply by the square root of 3. So we would do 5 times the square root of 3, which is just simply 5 root 3. So x, 5 root 3. So you'll notice with these shortcuts, it's great. I don't have to do the Pythagorean theorem. I don't have to really simplify the radicals. It's just a very quick way for me to find the missing sides. And we do this and we learn these because this shows up frequently in the work that we're going to do. So the next example, same deal. I've got a 45, 45, 90 triangle. And so in this case, what I'm going to do is I'm going to be like, all right, the legs are equal to one another. So if this leg is 2 root 2, then of course this leg is 2 root 2. So x is 2 root 2. Now, the other thing we knew is that in a 45, 45, 90 triangle, to go from the leg to the hypotenuse, you multiply by the square root of 2. So I would say 2 root 2 times the square root of 2 is equal to y. And then when I multiply this together, I get 2 square root 4. And square root of 4, of course, is 2. And 2 times 2 is equal to 4. So y is equal to 4. And I got that by multiplying the 2 root 2 by another square root of 2, and then simplifying my answer. So in this case, it's a little bit different. In this case, we're given the hypotenuse in this 45, 45, 90 triangle. And so what we're going to do is we're going to still follow the same rule and say, okay, to go from the leg to the hypotenuse, I would multiply by root 2. So here's what I know. I know that x times root 2 must equal 6. Because to go from the leg to the hypotenuse, I multiply by the square root of 2. So x times the square root of 2 equals 6. And then I'll solve this equation by dividing both sides by the square root of 2. So I get that x is equal to 6 over root 2. Now remember what we learned the other day. We cannot leave an answer with a radical in the denominator, so what I'm going to do is rationalize the denominator by multiplying the top and the bottom by root 2. And I get 6 root 2 over the square root of 4. And of course the square root of 4 is 2. So I get 6 root 2 over 2, which is equal to 3 root 2. So I followed the same rules, and then I just need to simplify my answer. So I found out that x must be 3 root 2. And then in a 45, 45, 90 triangle, the legs are equal, so that means y is also 3 root 2 as well. And I'm done. All right, let's move on and look at the next examples here. These are some 30, 60, 90 triangles. And so, again, the relationship is from the short leg to the long leg, we multiply by root 3. And from the short leg to the hypotenuse, we multiply by 2. So in this case, because the only number I've given is this is 6, I'm going to use the relationship from the short leg to the long leg and say, okay, x times root 3 is equal to 6. Then I will divide both sides by root 3. And I get x is equal to 6 over root 3. But again, I need to rationalize my denominator, so I'm going to multiply both sides, or excuse me, not both sides, but the both top and the bottom of my fraction by the square root of 3. And I get 6 root 3 over the square root of 9, which is just 3. And then 6 divided by 3 is 2. So I get 2 root 3 for x. And then, to go from the short leg to the hypotenuse, I double it. So I would do 2 root 3 times 2. So I can multiply these coefficients together, which gives me 4 root 3. And then for number 6, here's my short leg here. So to go from here to here, from the short leg to the hypotenuse, I double it. And from the short leg to the long leg, I multiply by root 3. So my hypotenuse is the number I have. So what I'm going to do is say, okay, the short leg, y, times 2 is equal to my hypotenuse. And then I will divide both sides by 2. And I get that y is equal to 3 root 2. And then once I know y, to get x, I simply multiply that short leg y by 3 root 2. So x is equal to 3 root 2 times root 3, which is equal to 3 square roots of 6. So x is equal to 3 root 6. So while those are your 30, 60, 90 triangles and 45, 45, 90 triangles, I'd say the most important thing you do is when you're doing your assignment, you have your notes out in front of you, and you draw those arrows, and you work them out just as I did there. Now, the other problems we're going to have on today's notes, there's 2 more. And the next one is if you have an application of 30, 60, 90, and 45, 90 triangles, 45, 45, 90 triangles. So the first thing I would do in this case, anytime you have a triangle with 2 angle measures there, I would find the third. And so this is 135 degrees, which leaves 45 degrees here. And then you think about which of these angles are the most important to us. And so what I mean by that is like, we've learned about 45, 45, 90 triangles. We've learned about 30, 60, 90 triangles. We never really learned about 105 degree angles in a triangle. So that's the angle I want to cut out. And the way I'm going to do it is by drawing an altitude. Because you'll notice when I draw this altitude, if this is 45 and this is 90, then this is 45 degrees. And then if this is 30 and this is 90, then this is 60 degrees. And together they add to 105. So now I've got a 45, 45, 90 triangle and a 30, 60, 90 triangle that share a side. So what I'm going to do is just apply what I've learned. So to go from the hypotenuse to the leg, or excuse me, backwards, to go from the leg to the hypotenuse, I would multiply by root 2. So of course, what times root 2 gives me 6 root 2? is simply 6. So this part is 6. Now in a 45, 45, 90 triangle, pause.
Good afternoon, Boulder High School. If you're in the building and would like about 3/4.
All right, sorry for that interruption. Just the announcement came on. So in the 45, 45, 90, if the leg is 6, then of course this leg is 6 as well. And that's not part of my perimeter, but now I've got part of my 30, 60, 90 triangle. So remember what we learned. In the 30, 60, 90, to go from the short leg to the hypotenuse, you multiply by 2. So 6 times 2 gives me 12. And then to go from the short leg to the long leg in a 30, 60, 90 triangle, you multiply by the square root of 3, which makes this 6 root 3. And now to get the perimeter of this triangle, I'm going to add up all the way around it. So starting here all the way around, I have 6 root 2 plus 12 plus 6 root 3 plus 6. 6 root 2 plus 12 plus 6 root 3 plus 6. And then I combine any like terms, and in this case, the only like terms I have are 12 and 6. So the perimeter of this triangle is 18 plus 6 root 2 plus 6 root 3. And then, of course, whatever the units are, in the linear units in this case, it's perimeter. All right, y'all, just very quickly, we're going to set up the Pythagorean system, and I'd like to do this in just a couple minutes, so I'm just going to go ahead and set it up quick, and we'll run through it. And I'd like for you to try this one on your own, based on what we did in class the other day, and then check your answer. All right, so maybe pause and give it a shot based on what we did in the 9.2 notes. So, first we'll call this x, and then this is 25 minus x. Then we'll set up Pythagorean theorems for triangle 1. X squared plus h squared is equal to 5 root 2 squared. For triangle 2, I get that 25 minus x squared plus h squared is equal to 25 squared. So we simplify this. X squared plus h squared is equal to, this gives me 50. 5 root 2 squared is 50. And then over here, I get, when I FOIL this out, remember, I get 625 minus 50x plus x squared plus h squared is equal to 625. Now remember, the crux for solving this is we're going to substitute for x squared plus h squared. So over here, where I see x squared plus h squared, I'm going to put a 50 in its place. So I have 625 minus 50x plus 50. Just substituted that 50 for x squared plus h squared equals 625. Then I'll combine my like terms, and I get 675 minus 50x is equal to 625. Then I'll subtract 675 from both sides. You get negative 50x is equal to negative 50. So then I get that x is equal to 1. Now I'm going to go back to my triangle over here, and I'm going to plug in 1 for x, which makes this part 24. Now you all, right now, to solve for h, I could plug in and say, hey, 1 squared plus h squared is equal to 50. I have my equation right here. And that means 1 plus h squared is equal to 50, which makes h squared equal to 49. So h is equal to 7. The other thing you could have done is right here, you notice that this triangle, let's see, I want to focus on this triangle. You should notice that this is 24, this is 25, so h must be 7. That is a Pythagorean triple. 7, 24, 25. And if you notice those things, you all, it just makes your life a bit easier. So, now we've done 2 of those systems together. We'll do another one on Monday. Hopefully that makes sense. I appreciate your patience. And please use these videos and the notes while you do your homework. And then we can talk about any problems you're having on Monday. All right, I hope you have a wonderful weekend.